In Lesson 6.3, Polygons and Angles, you will find the sum of the angle measures of a polygon, and you will also find the measure of an interior angle of a regular polygon. We're going to start out by just going through some basic shapes and help figure out how many, or the sum of the angle measurements. We're going to start out with the triangle. A triangle is a polygon with 3 sides. It obviously makes one triangle. And the sum of the angles in a triangle, you should know from previous courses, is 180 degrees. So the 3 angles in a triangle added together are 180 degrees. Next, we have the quadrilateral. A quadrilateral is a polygon with 4 sides. Now, I can divide a quadrilateral into 2 triangles. Now, you could divide it into more than that, but we're looking for the fewest number of triangles you can divide it into. It can be divided into 2 triangles, and if you take this angle, and this angle, that's a total of 180 degrees. But then we also have this one, and this one. And if we add all of those angles together, that's going to be the angles, the sum of the angles for the quadrilateral. So what we have is 2 triangles. So I'm going to do 2 times 180. 2 times 180 degrees is 360 degrees. A pentagon, if I want to divide that into triangles, into the fewest number of triangles, I'm going to just pick one of the vertices and go from there, connecting it to all of the others, and I end up with 3 triangles. If each one of these triangles, if their angles add up to 180, we have 180 plus another 180 plus another 180. That'll give us all of the angles of the pentagon together. So that's going to be 3 times 180. 3 times 180, that's going to be 540 degrees. We're going to do one more, and then you can fill in the rest of this chart on your own time. A hexagon is a polygon with 6 sides, and if I just choose one of the vertices and start drawing diagonals in across to the other vertices, the fewest number of triangles you can divide a hexagon into would be 4. And if each one of these is a total of 180 degrees, it's going to be 180 degrees times 4. Which that's going to equal 720 degrees. Now, without filling in the rest of this chart, can you see a relationship between the number of sides on the figure and how many triangles it makes? A 3-sided figure makes 1 triangle, a 4-sided polygon makes 2, 5-sided makes 3, and a 6-sided makes 4. A 7-sided is going to make 5 because it always makes 2 less triangles than the number of sides. So if I wanted to skip all the way down here to what's called an n-gon, or a polygon with n number of sides, the number of triangles it's going to make is the number of sides minus 2. And then to find the sum of it, it's going to be, the sum is going to equal the number of sides minus 2 times 180 because each triangle is 180 degrees. And the number of triangles it makes is going to be the number of sides minus 2. Just a quick vocab word. An interior angle is an angle that lies inside a polygon. So that's what we were finding is the sum of the interior angles. And that formula right here is also in this box. The sum of the measures of the interior angles of a polygon is n minus 2 times 180, where n represents the number of sides. Now we're going to use that formula to help us find the sum of the interior angle measures of some different shapes. Find the sum of the measures of the interior angle of a decagon. Well, a decagon has 10 sides, so the angle sum is going to equal the number of sides, which is 10, minus 2, because it's always going to make 2 less triangles than the number of sides, times 180. So then you can, at this point, either type in your calculator 10 minus 2, hit the equal sign, and then times 180, or make sure you put this in parentheses so it knows to do the subtraction before it does the multiplying. So 10 minus 2, that's going to be 8, and then 8 times 180 is 1,440 degrees. You may want to pause the video and try the next 3 on your own. A hexagon has 6 sides, so the sum is going to equal the number of sides, which is 6, minus 2 times 180. 6 minus 2 is 4, and 4 times 180 is 720. We had done that earlier in our table. 720 degrees. That's the sum of all the angles put together. Next, we have an octagon. An octagon is a polygon with 8 sides, so the sum of the angles is going to equal the number of sides, which is 8, minus 2, because it always makes 2 fewer triangles than the number of sides, times 180. So 8 minus 2 times 180, we're going to have 6 times 180. That is 1,080. The sum of the interior angles is 1,080 degrees. And the last one we have here is a 15-gon. So the sum is going to equal the number of sides, which is 15, minus 2, because it always makes 2 fewer triangles, times 180. So 13 times 180, that's going to be 2,340 degrees. So the sum of the interior angles is 2,340 degrees. Now a polygon that is equilateral, it means all the sides are congruent, and equiangular, meaning all angles are congruent, is called a regular polygon. Since all the angles of a regular polygon are congruent, their measures are equal. So what we're going to do next is not just find the sum, but we're going to find what just one interior angle is going to measure if it's in a regular polygon. And to be regular, all the angles are the same size. So what we're going to do to find just one angle, is we're going to take the sum of the angles and divide it by the number of angles. Now this only is going to work for regular polygons, because regular polygons have angles that are all the same size, so you can find the measure of just one. Let's start with an octagon. The first thing we're going to want to do is figure out what the sum is. The sum is going to equal the number of sides, which is 8 minus 2 times 180. 8 minus 2 times 180 is going to be 6 times 180, which is 1080. So once we know the sum, now we can take that 1080 and divide it by 8, since there's 8 angles that are the same size. So 1080 divided by 8 is 135 degrees. So one angle in a regular octagon is going to have a measure of 135 degrees. You may want to pause the video and try the next two on your own. A heptagon is 7 sides, so the sum is going to equal the number of sides, which is 7 minus 2 times 180. So the sum is going to equal 5 times 180, which is 900. Now if we want to find just one in a regular heptagon, we would take 900 and divide it by 7, since there are 7 angles in a heptagon. And that's going to be about 128.6. It turns out to be a real ugly number on your calculator, so we're just going to round it to the nearest tenth. So 128.571 and so on, it keeps going with some different numbers on the calculator. So to the nearest tenth, it's going to be 128.6, because we're going to round up in this case, degrees. And the last one, is a 20gon. So for a 20gon, we're going to find the sum by doing the number of sides, which is 20 minus 2 times 180. So we're going to have 18 times 180, which is 3,240. Now to find the measurement of one angle, we're going to take that sum and divide it by 20, since there are 20 angles the same size. And that works out to be 162 degrees.